Right, this video is about uniform motion, and it's part 3 of a video series, uniform motion. And we talked about in what uniform motion means in part 1 and part 2. It's just a constant speed or constant rate. And we used, in the part 1, we used equal distances. In part 2, we used two distances adding up to another number. And this time, we're going to have distance 1 plus some number equals distance 2. So it's kind of similar to the previous one actually. So this is part 3 of that video series. So we have two examples in this one. The first example I'm going to go through with you, and then the second example I'm going to encourage you to try it yourself and give you the answer at the end. So let's start by reading the question, which is always super important. Ruth was hauling a wide load out of Portland at 4 a.m. She headed south from exit 50 at an average speed or rate of 25 miles per hour. Then Jamie headed south also from the same exit, so they're going in the same direction, at 11 a.m. in her Toyota. By 3 p.m. the same day, Jamie was 17 miles ahead of Ruth. What was Jamie's average speed? So what we're looking for is RJ, the rate of Jamie. All right, usually it helps to draw a diagram. So what ends up happening is Jamie is going to end up 17 miles ahead of Ruth, even though Jamie started later. So what I'm going to do is draw an arrow that, this isn't a very straight arrow, but this represents dr, which is the distance of Ruth. And then we know that Jamie went further. She ended up 17 miles ahead. So I'll put 17 here and I'll say dj is Jamie's distance. So this diagram will tell us how to make our main equation. So our main equation is going to be dr, distance of Ruth, plus 17 miles equals the distance of Jamie. And so similar to the other types of problems, all we need to do is figure out, we need to plug things in, and as always, d is RT, so distance is rate times time, so the rate of Ruth times the time of Ruth plus 17 equals the rate of Jamie times the time of Jamie. And RJ is going to be our unknown that we're solving for. So over here under the diagram, I'm going to write down what I know. I know the rate of Ruth. It tells me that she was going 25 miles per hour. I don't know the rate of Jamie, but I do know something about the times. So the time of Ruth traveling, she left at 4 o'clock in the morning, and then we're stopping the time at 3 p.m. So how many hours is that? What I like to do is think about 4 o'clock to noon. So between 4 and noon, that's 8 hours, and then another 3 hours, so that makes 11 hours of travel time. Then the time of Jamie is going to be, Jamie left at 11 a.m., so 11 a.m. to noon is just 1 hour, plus 3 is 4 hours. So we actually have the times. You just have to be able to add. You can use your fingers or use a clock, but we have to be able to figure out the times on our own. So now I can just plug everything in. So the rate of Ruth was 25 miles per hour. I'm going to multiply that by the time, which is 12. Add 17 equals RJ times the time of Jamie was 4. And now I can simplify. I have to multiply 11 times 25, which is, using my calculator because I'm lazy today, 275, and then I need to add 17 to that, and I get 292 equals 4 times RJ. Then I divide both sides by 4 to solve, and I get RJ equals 73 miles per hour. And that was exactly what the question was asking for, so I don't have to take any further steps or plug anything else in. And so that's it for that type of question. It's pretty similar to the previous, to part 2. I'll give you one more example. and you can try it on your own and then pause the video to check it when you're ready. So number 9, it's a very similar question, just different numbers basically, so go ahead and try it, and then check back with me in a moment. Alright, let's check the answer for number 9. I ended up getting the rate of Jeremy is 65 miles per hour. I drew my diagram very much like the last problem, DC plus 15, the distance of Chase plus 15 equals the distance of Jeremy, since Jeremy ended up 15 miles ahead. I knew the rate of Chase was 30, and I knew the time of Chase was 6 hours because I figured out from 7 a.m. to 1 p.m. that's 6 hours, and the time of Jeremy was 3 hours from 10 a.m. to 1 p.m. And then writing in my main equation here, I substitute always D for RT, and then I substitute all the stuff that I knew and solve the equation for RJ, and didn't have to take any further steps since that was what it was asking for. So I hope this was helpful, and thank you for watching.